We're learning how to run our linear regression into the RStudio. First, we start with install the packages that we need in this lecture. So I'm gonna first start with tidyverse. Tidyverse allow me to install packages.tidyverse, allow me to drag my CSV file and use the ggplot tool where we can plot our data. I'm gonna just library tidyverse. So I'm gonna run this one. I also need to install dot packages. I need CA tools. CA tools allow me to separate my data into the training. I'm gonna run this one library CA tools. Okay, run it. So this is all the packages that we need in this lecture in linear regression. This one allow me to drag my CSV file, and this one allow me to separate my file to train. And so I'm gonna name my data as symbol underscore model. I'm gonna drag read .csv file. I have my CSV file is called in here machine learning house price, so I'm gonna give him the path from here. So I'm gonna upload my CSV file into the, I have to give him first a C quotation mark, and then I have to change from this one to backslash. So machine learning, and I have backslash, this is house price, house underscore price, and dot CSV for CSV, and then we capital enter. We'll run this model. That's gonna view our data. So view have to be capital symbol model and capital enter. So I have my data as room number, there's a crime rate, residual area, this air quarter, this is age, distance 1, distance 2, 3, 4 teachers until I have the price. So I need to build a new model to predict the prices depend on my independent variables, all these independent variables. So all this is numerical data because we're talking about supervised machine learning. If you don't know what is a supervised, please back to the previous videos. We describe in more details. So anything I would describe here, I just described the theoretical concept before this lecture. So back to the previous video, you'll see all the concept there. So now before you start, you have to play with your data, okay. So you'll check with your data, you'll check for example the structure of your data is called symbol.model. If you plus that, so you'll see the structure of your data. You'll take a quick view. For example, if you know this is room number, so this is number supposed to be number, and the price supposed to be number. If you have the column name is the format is unimprobable, so you have to check. So structure is so important, allow you to check. And we have also the head function dot my data is called symbol model. So the head will give me the six first rows from each column. If I have anything, I will check. Also you have summary if you need to check your summary of your symbol model. And then here we go, I have the summary for all my data. So this is the function to play with your data. Check if you have any missing things. Now I need to check before if I have any missing value. This is so important, missing value. If I any missing value, so I have to check miss, because the missing value will affect on your running your code. So missing value equal to column dot sums. This is dot na, and I have to give him my data as symbol model, and then here we go, I have to print give him miss value, and then here we go. So if for example you have 2 in here, 3 in here, that means you have to delete the missing value. Otherwise you will receive an a code. That means you have a missing value in this, because we talk about supervised machine learning. And corresponding to each x, you have to put a value for y. Otherwise you'll have missing value. Okay, so you check your, okay, now it's time for split our data. Now it's time for split our data. So for splitting our data is we have to set dot seed. Set dot seed into where you have to put any value for seed. And what does that mean? We will split our data into train and test. And why we do that? We need to check our model on the train data, and then we will keep 20% is unseen. The model, we don't see this 20%. After we do the analysis on the train, we can check if our model is working properly on the test data. And the set.seed allow you to choose. If you choose 8% for a train and 20% we keep them for the test. And set.seed, it will allow you to keep the same value every time you run the equation. You will have the same value, the same 20% you choose to select them for the train, and the same 20% you select them for the test. It's not changing. And that's why you have to set your seed. Otherwise you will have different value every time you run. So split equal to sample dot split, and I have to put my sample model data, and in here I have to give him the data. I have to give him the split ratio. Split ratio equal to 0.8, and run this one. And then I have to give him my train data. So my train data equal to subset sample data. I have to give him my sample model data, and then split is equal to true. So if this one is true, the second one have to be wrong. My test underscore data, it is equal to subset, where subset is my data is sample.model, sample underscore model, and the split have to be. So if it's not true, that means the other one is supposed to be false, and supposed to be false. So this is how you split your data. The first one is true for 80%. The second one, give me the rest. If it's not true for the 80%, give me the rest for 20%. So now we have, if you can check the environment, you will see we have a train data 335 observation, and only for test 125 observation. So this is, we successfully separate, and now the set.seed will keep these values anytime we run this, the same values observation. Okay, we set our seed. Now it's time for linear regression model. Yeah, I was gonna start with symbol linear regression, symbol linear regression model. Okay, so the simple linear regression is you have one value y and one target variable y, and one independent variable is x. It's simple, like nobody used that, but I was gonna run it. Symbol underscore linear regression equal to ln function. This is for linear regression function. So ln function, we need to predict the price, so my y is gonna be the price, and I have to use the type, I have to use the tilde, and my x is called to be room number, room underscore number. So I'm gonna build my room number, supposed to be my input independent variable x, and the price is my target variable is y. So give me the data equal to train data. That's why we separate our data. First we run our model into the train, and then we have give me summary of my data, give me summary for symbol linear symbol underscore linear regression model. Okay, close, enter. Here on this one. Okay, now give me the summary. Give me the summary of my symbol linear regression, and here we go. Give me the summary. So now let's gonna see what does this mean. We talk about what is the residual in the previous video in more details, and this is our coefficient. This is our beta 0, and this is our beta 1. So the room number every 1 unit changing in the room number is change. It can change it can change the price of the houses by 9.1214 units. So each one change from room number, its effect on the price by 9.1214 value. And this is the standard error. We talk in more details in the previous video. This is the t value, and this is the p. This is the probability we calculated from the t. And you can see we have in here 3 stars. That means this is highly significant. That means the room number is highly affecting on the price. And because the p-value is very low, that means this value is highly affecting on our price. This is just for simple linear regression. Now we're gonna go for more details for the multiple. This is the most important, is multiple, not simple, when we have more than one x. So I'm gonna go multilinear regression, need a space. So I'm gonna give him multi underscore linear regression equal to ln function. Use the ln function also. So now my y is the price, and I use the tilde and then dot. This dot will give you all the independent variables or the x in your data, and then my data equal to the train data. We work on the train data, so give him train data and then run, and then give me summary, or give me the summary of my symbol on my multiple linear regression, and then here we go. So now you will check, you will have all the inputs, all the independent variables, it is x variables, and you have the y variable. So you can check who has the more significant impact on the price and who is not. You can see this room number have highly significant impact on the price, but the others, for example, this is a crime rate, have nothing to do with the price rate. There's not an actual relationship between them. And from the data you can check, and you can exclude these variables and keep the one just that give you the highly effect on your data. So this is very useful. You may execute some of your x variables because it have nothing to do with is not significantly impact on your data, so depend on your data. We can check the R multiple of 0.17. That means it's only 71% of our data is can captured by this relationship. And what else you can check? We have the residual standard error, and we have the F statistics, and we talk what that mean everyone in much more details in the previous video. So now okay, it's gonna go more deeper. Now we just fit our model, and now it's time for you have to check your residuals. Residual analysis is so much more important. Without them, you'll never know what is your relationship between this. So first, let's gonna check. Give me the histogram for the residuals. For the residuals, yeah. Residuals for my residuals, and my data it is for multiple linear, not for train data. My train data is gonna check. Okay, I have to give him my, sorry for that, I have to give him my my multilinear regression, and then I'm gonna check. So the model have to be, the principles have to be, your residuals have to be normally distributed. That means it is the from the x and from the y, from the right side and from left side have to be normally distributed. If your data is normally distributed, that means your model is not perfectly fit for that. And this is the first one you check for residuals. And also we have to check the plot, and I have to give him my multi linear regression and plot. Sorry for that. Multi linear regression, which equal to 1. Now it's gonna run this one. So you will check. We have actually plot from 1 into 6, so you can plot from 1 which equal to 2. He will give you the most important plot that you are looking for. You have to check for residuals. So the first one, when we give him equal to 1, he's give me the difference between the fitted and the residual. So from the fitted and the residual, you can check your model is not like perfectly capture all the data. And from the QQ residuals plot, from QQ, this is which one is equal to 2. This one, you can see your model is not like perfectly fit. It is good in some part, but this part you can see you have highly values is not fitted. So the black value is supposed to go and pass through them, pass from the middle, so is fit all your data, but this is impossible. You cannot get that perfectly. So that means your linear regression model is not perfectly perfect for this data. And you can also check, there's a lot of plotting here. You can check, for example, I can check, sorry for that. You can check also if you have for 3, which is equal to 3. And if you check equal to 3 and give him enter, you will have another plot, and which is equal to 4. 3 and 4 you will have into 6. So this is an easy way you can plot the most important plot and you get the insight from your data. So you have to check for your residual. This one is so important, and which is equal to 1 and which is equal to 2 is so important to give you the residuals. You can check from here QQ plot if your model is fit or not. So you can see it's not perfectly fit in this part, is what is good from this part, and that means your model is not perfectly fit. So now it's time to check. We just run our model and give us the model and fit it on our data. But now if I need to calculate the mean square error, if you don't know what is the mean square error and need to do some calculations, please back to the previous video we describe in more details. So if I need to calculate the for example, I'm gonna name it train underscore a. Now I need give me predicts. So predicts, my model is multilinear regression, and my data is a train data. What I am doing here, I need my model. I'm gonna train the model that I built on my training data, so I get the y hat, the predicted y from it. I'm gonna do the same with the test underscore a equal to, so predicts, this is multilinear regression, this is multi-linear regression on the test data. So what I'm doing here, I'm trying to predict okay, I'm trying to predict my model on my training and test sets. So if we check the environment now in here, so I have train and test. Okay. I need the purpose from that. When you run your model at the first one, he will give you the total model with all this summary, but he's not give you. And now I'm trying to, I give him my train data, I give him my test data, and I tell him, okay, go and predict my model. So put my model on my train data and put my test data, because I need to get the y hat. That's why, because I need to calculate the mean square error. So the mean square error equal to the mean square error in here. what I'm trying to calculate the mean square error is equal y minus y hat. This on the power is on power 2. So y minus y hat, my train data, the dollar signs I need to give me the price. This is my y, real y, minus y hat is the train A that I'm just calculated, train A, and this one have to be over the power 2 and close this one. Now I'm calculating the mean square error and go for that. So I have a 24. Now I'm gonna do the same mean square error and I will calculate that for the test data dollar sign. This is to check the model on unseen data. So we check our data if it's perfect fine or not. Test minus at a, this is supposed to be onto the power of 2, and then we have to close it, and then I have to close it from here. So this is run, and now so what if I have done? I have something test data price minus test underscore a power 2 over 2. Okay, have one. Okay, have one from here. Not two. Okay, so I can check my mean square error is 24 for train, and my for test is at 23.6. It's almost clear. It's not perfect, but it's so close. That means they have. Okay. That means my mean square error is so close to the train data. That means my model is working properly. Now, if I need to calculate my train square, so I can easy to interpret that. So if you need easy way to interpret, just get the square root from the mean. So I'm gonna get the square root from the mean. That's why I'm gonna train. I need residual mean square error. This is equal to, give me the square. This is where I get the square. So it's easy to interpret it, and let's give you, okay, give me the square mean root of that and give him, I have, okay, now I have to give him my test root mean square error, and equal to, this is square is the root, and then I give him my test, the mean for the test. Now I will get the root square for my data, so it's easy to check and interpret it. What is hidden wrong in here? My mean square, okay, test data price, my test data, okay, so my is working properly, equal to mean test data price minus test. Okay, what is wrong with that? Square mean, yeah, let me check. Okay, maybe we have wrong with this one, and check the mean first, mean working properly. Okay, equal to test RMS, this is our mean, and we have just to close him from here, and here we go. Okay, now if you can check the train and root mean square error, so we take the root for the mean, and the root mean square error in here, where is the root mean square error? Why is not showing in here? Multiple R root mean square error. No, run again. This one mean square, this one, and then we have root mean square error. Still we get the error. And we have problem with this one. Run. Okay. Maybe I don't run one of these guys. Let's gonna run that together. Okay, and then we run this guy together. Okay, if I'm getting now, I'm getting those guys together, run. Mm, okay, close. We need another one in here. We need another one in here. That's why. Okay, run. Okay, now I can see we can check the train root mean square error. So the purpose we calculate this first, we need to predict, we need to get the y hat, and then the mean square error is y minus y hat. Enter the power is power 2, and y minus y hat and then the power of 2, and then I have to calculate the root mean square, and that's why it's easy to interpret it and check. Now I can see the train RMS is 4.9 and my test RMS is 4.8, so that's why it's so close to each other. That means both of them they are so close that both of them working properly. So this is all you need to consider in your calculations. For example, you have to check your residuals, you have to check. And in here we have calculated the r square. We have r square, but if you need to calculate your r square, so you can run it by yourself. As the model is only give you the r square for your train data. If you need to calculate the r square for your test also, so we have the run the formula. Let's gonna check the r square for train first, and we check if it's give me the same value as the model is give me. So I'm gonna gonna take the equation directly from here. I'm not gonna miss anyone. This is train RSS, and then we give him for them. And if you don't know what is this equation for the how to calculate the r square, please back to the previous video where we talk in more details. So we have a train, we need to calculate the train r square. So first we have to calculate the residual sum of squares. Sum residual, this is train for our price. This is y minus y hat price, and this is our train A. So we have to give him the sum. Train data equal to price. This is y minus y hat. This is our mean, and you just take the sum for the mean. So this is the residual sum of squares, and we have to give him the sum for the total sum of squares. Total sum of squares is where train data, our train data equal to here price. So we have to give him the price, and our mean coin, this is our data, have to give him is equal to price. So if we run our model now, we will collect you'll check the r for, and this is train r square 1 minus train residual sum square on the train total sum of squares. So if you don't know what I'm talking about, please back to the previous video. So the training r square 0.7154 is the same what the model give us. It's 0.715, 0.715154. If you need to calculate the r square is for the same, but for here you calculate it for the test, and you check between them for the test. So you have just to give him from the train, you give him this is test, and this one train A, you give him test A. This for test, and you have to give him here train data. This is test data, this is test data, and train data, this is test data. You have to give him the data, and we have to click on this one. You have to run our total, and then we have the train, and we have the test r square. Where is the test r square? Test r square. We don't have test r square. This is 4 point. Okay, this is test A, test train, test data price, mean test data. Okay, and it's gonna run it again. We have some. Okay, it's working properly. Train. Where is the test r square? Test data, train data, test r square. Supposed to be in here. This is so weird. So this is test A. Test underscore A train. Oh, because I gave him a train, man. I have to change this one to the test, and I have to change this one into the test, and I have to change this one into the test. So because he gave me now two values, now if I run this one, I will have the test r square. Where is the test r square? It is 0.709. It is 0.709, and it's very close to the train. The train is 0.15 and this is 0.7. So this one is the how to calculate the r square for the test data. Just to give how to give him the sum. The residual sum of squares is where you give him the sum, and you give him the sum of squares. This is your data. Test data, you take the price y minus y hat, the predicted one, over the var by 2, and you give him the sum, and divided by the total sum of squares. So 1 minus a train residual sum of squares divided by the total sum of squares. This is how you calculate the r, and you check the test r square of 0.709 and the train r square of 0.7093. So it's very close to each other. Because I give him 2 times. The train r square is about 1.715. So this is all you need to know about how to calculate the linear regression. From 0 to scratch, please be careful when you run your linear regression, because you will face any problem and then you have to solve it. Thank you for watching. See you in the next video.